Hello, this is Mrs. Myers. Today's lesson is about midsegments of triangles. When we have a triangle, there are going to be something called midsegments, and they actually have really special properties that occur. So it helps us to solve for different lengths, etc. in a triangle. So let's first define a midsegment. A midsegment is a segment connecting the midpoints of two sides of the triangle. So if you look at this triangle here, if we find the midpoint of side CA and the midpoint of side CB, and we connect them, connect them right here, that connected line from L to N is called the midsegment. Okay. So there's something called the midsegment theorem, which gives us the relationship that that segment has with the rest of the triangle. So two things happen. When you connect those midpoints, that midsegment ends up parallel to the third side, parallel to the side that it's not touching, okay? So parallel to the third side. So that's the first thing that happens. It's parallel. The second thing that happens is that that length, the length of DE, is actually half, exactly half of the length of that parallel side. So I like to think of it this way. 2 times the midsegment equals the parallel side. Okay, so if you can remember that, I keep repeating that, then you'll be able to write equations and solve in different examples. Now, notice that there's actually 3 midsegments that you could draw in every triangle, because you could connect the midsegments of DE and EF, but then you could also connect the midsegments of EF and DF, etc., and then the third one here. So you actually can draw 3 possible midsegments in a triangle. So if we look at these questions here, name the 3 pairs of parallel segments. So every midsegment, remember, is parallel to the side that it's not touching. So in this diagram, midsegment RS is parallel to DF. And then we have midsegment ST parallel to the side it's not touching, which is DE. What would be the last one? RT is parallel to, going to be EF. Okay, so all of those parallel relationships then help us with some angles. Remember, when we have parallel lines, we can think of alternate interior angles, corresponding angles, alternate exterior angles, and same side interior angles, right? Well, in this particular case, we're really going to be looking for corresponding angles. Corresponding angles are going to help us here to solve for different, because we really don't have any of those other relationships happening. Well, actually we do have some alternate interiors, etc., but mostly corresponding. Okay, so if EDF is 42 degrees, the question is, what other angles would be 42 degrees? So if you think of the parallel lines, these two, corresponding angles cut by this transversal, this 42 degrees would be matched here. But if you also think about the other sets of parallel lines, you've got 42-degree angle, another set of corresponding angles right here. So it's kind of hard to see everything. We've got it here, here, and here. So what other angles would be 42 degrees? Let's just name the angles. Angle ERS, ERS, right? And angle STF, STF. There's actually one more, and it does have to do with an alternate interior angle right here. So RST, angle RST. Okay, now that's based on knowing that the midsegments are parallel. The second piece of our theorem there said that it's half the length of the third side. So if RT in this diagram, RT is 12, it's asking what is EF? Well, remember, 2 times the midsegment equals the parallel side. So in this case, if the midsegment is 12, 2 times 12 would equal EF. So that would be 24. So then what would ES be? Well, remember, S is the midpoint. So ES is also half of that side. So that would be 12. Name 2 segments congruent to RS. Well, here's RS. Remember, it's half of the parallel side, which is cut in half. So the 3 red segments are actually congruent to each other. I could put a double congruence mark on each of those. So DT and TF are going to be congruent to RS. We can do that in every direction, right? Here's a triple and a triple. This one would be your triple, etc. Okay, solve for x if TS is x minus 1. So TS is x minus 1, and DE is 3x minus 7. And then find DE and TS. Okay, so again, 2 times the midsegment equals the parallel side. So you're going to have 2 times the midsegment is x minus 1 equals the parallel side, 3x minus 7. Distribute this and solve for x. If x is 5, now we plug that back in, and we get DE equals 3 times 5 minus 7, which is 8, and TS equals 5 minus 1, which is 4. Makes sense that one is half of the other one. Okay, so 19 through 21 here, again, we just have to think about 2 times the midsegment equals the parallel side. So you guys solve for x in these 3. I'll do number 20 with you first, and then you can do 19 and 21 yourself. 2 times the midsegment equals the parallel side. Okay. Okay, so hopefully you paused the video and tried those yourself, and here's the answers. Okay, so this is going to bring in the midpoint formula, which you guys practiced on your own a couple weeks ago. Here's the formula again. It's just the average of the x's and the average of the y's. It gives you an xy point, this formula, okay? As long as you have x1, y1, x2, y2, you plug into your formula and you can get your midpoint. So that's going to relate to our midsegments of triangles because we're finding the midpoint of each side and then connecting them to get the midsegment. So this one is just on the number line, not using the midpoint formula. This is just what's halfway between -3 and 7. So this is strictly an average. So 2 would be the midpoint of those points on a number line. Again, that's not the midpoint formula. This is just saying if you have a point at -3, -2, -1, 0, 1, 2, 3, 4, 5, 6, 7 on a number line, what's the halfway point? Well, it's going to be at 2. That's going to split this in half. Okay, but the second one and the third one are both using the midpoint formula. So if we label our x1, y1 and x2, y2, we are just finding the average of the x's. So add the two x's together, divide by 2. Add the two y's together, divide by 2. You're going to get -2/2, comma, +2/2. So our final midpoint is -1, 1. You guys, well, let's do one more together, and then you guys can try on your own. x1, y1, x2, y2. Just add the x's and add the y's and divide by 2. 2 minus 3 is -1, so we got -1/2, comma, 4/2, which is -1/2, comma, 2. That's your midpoint. Okay, so you guys can try 3 and 4 on your own. Pause the video, try them. Okay, so check out your answers here. See how you did using that formula. So here is how we would relate this to the midsegment. Triangle ABC has coordinates 3, 9, 3, 9, 5, 1, and 9, 5. That makes a triangle. D is the midpoint of AB, and E is the midpoint of AC, and F is the midpoint of BC. Graph the points A, B, and C. After graphing the triangle, find the coordinates of the midpoints and sketch the midsegments. So we just need to find the coordinates of these midpoints by adding the x's of AB to find D and the y's and using the midpoint formula, right? So we're using A and B, those are the endpoints, where the midpoint is D. So we're going to do 3 plus 5/2 and 9 plus 1/2 to get our midpoint at 4, 4. Over 4, up 4, and the midpoint would be right there. My smartboard's a little bit off here, so it's kind of hard to get it accurate. And then for point E, it's the midpoint of AC. So we're going to be using A and C as our endpoints. A and C. So we're going to do 3 plus 9/2 and 9 plus 5/2. Add the x's, add the y's. We get 6, 7. Over 6 up 7 gives us endpoint E. You guys find F. We're using the endpoints B and C. B and C. Okay, did you do it yourself? You should be doing it. B and C. 5 plus 9, and 1 plus 5. So that's 7, 3. Okay, and then you sketch the mid-segments by drawing those in there. All right. So that's pretty much it. The rest of this packet is practice. We're going to be doing a lot of this practice in class. I would like you to try to do just a couple of problems for me. Before class tomorrow. So do 3 and 9 and I'm going to have you do 23, but let's do 20 together. Remember, 2 times the mid-segment equals the parallel side. So 2 times mid-segment is 2x minus 10 equals x plus 4. Distribute and solve. Okay, we're just finding the value of x. So your job is to do numbers 3, 9, and 23 before class tomorrow, and then tomorrow we will do the rest. Okay, thanks.